Hello and welcome to my math companion. In the previous video, we examined a problem involving finding the area of an equilateral triangle which has sides of length 6 centimeters. And in that video, we examined the Pythagorean theorem approach. In this video, we will be looking at the Heron's formula and how it helps us in solving the problem. So let's begin. Heron's formula states that the area is given as the square root of s times s minus a times s minus b times s minus c. And when you first look at this formula, you might think 4 different variables to calculate the area? That seems extremely difficult. But don't worry, we'll make it really simple for you. So in this formula, a is the area, s is the semi-perimeter, which we will get to in a moment, and a, b and c are the side lengths of the triangle. Now this simplifies the formula a lot since you already know the values of a, b and c to be 6, 6 and 6, which means that you now just have to figure out s. So the semi-perimeter or s is exactly what it sounds like. It is half of the perimeter. So the perimeter is a plus b plus c, which is the sum of the side lengths of the triangle. And so the semi-perimeter is a plus b plus c divided by 2. So now we input our values of a, b and c in this formula and we find s to be equal to 9. So now we can just put all our 4 values, which is a, b, c and s, into Heron's formula and figure out the area. So the area would be 9 times 9 minus 6 times 9 minus 6 times 9 minus 6 and the square root of that entire product. And that gives us an approximate value of 15.59 centimeters square, which is the exact same value that we got in the previous method. Just like the previous video, I will now be examining the steps on how to find the area without using a calculator. In other words, I will be showing you how to find the simplified form of this entire square root. So let's begin. So we know this is the value of a, and 9 can be written as 3 squared, and since 9 minus 6 is 3, and since 9 minus 6 is occurring 3 times, we can write it as 3 times 3 times 3. And this can be written as 3 to the power of 4 times 3 to the power of 1. So what we're doing here is we're adding this 2 with a 1 and another 1. And we're keeping this 3 to the power of 1 just like that as it is. And we're doing this because 3 to the power of 4 is 3 squared whole squared. And whenever you have a square inside a square root, you can remove this part that's being squared and take it outside. So since 3 squared is being squared, and since everything inside the square root is being multiplied with each other, we can just remove this square and take 3 square outside the square root, which gives us 3 squared times the square root of 3, and that evaluates to 9 times the square root of 3. So this is the simplified form of this initial square root over here. And again, if you put 9 times the square root of 3 in a calculator, you would again get a equal to approximately 15.59 centimeters squared. So that is how you solve this problem using Heron's formula and the concept of the semi-perimeter. So in the next video, I will be looking at how to solve the problem using a trigonometric approach. See you there.